Hi, I'm Steve Ward. I'm a pre-sales consultant at Emerson, and in this session I'm going to cover the technical aspects of our Movicon HMI SCADA software. Now, as you'll see, Movicon covers multiple functions. It covers HMI, human-machine interface. It covers SCADA or SCADA, supervisory control and data acquisition. It also covers data collection, data logging. We also have scripting capability, and the key aspect is visualization. So you'll see how we can achieve that through the course of these slides. First, a safety moment. Emerson is a very strong believer in safety, both from a corporate point of view, but also for individuals, both our clients, our customers, our employees, and the general environment and the general public. I would say stay safe, and one of the ways to do that is to review your working environment for issues, not just on a regular basis, but every time you start work. Check for trip and slip hazards, make sure you adopt safe lifting practices, look for electrical issues, take care of desk and computer ergonomics, drive safely. If you're on site, wear appropriate personal protective equipment, adopt safe working if you're at height or using ladders, and understand fire safety, so alarms and exit routes. You're empowered to stop work if it's unsafe and seek rectification, either by doing that work yourself if you're able to and it's appropriate, or by seeking help from appropriate people. If there are any issues or there are any safety problems, you should report these, and that includes near misses. We want to make sure that we're not just recording things that have happened, but also things that might have happened, so we can be safe in future. And take a look on the right hand side here. Emerson has these 12 life-saving behaviours that we recommend you follow. Emerson's PLC division covers PAC systems, which is a PLC range including I/O. We have Movicon, we have IPCs, we have PAC Edge, and in this section we're going to focus on the HMI SCADA and connectivity functions that Movicon provides. As well as Movicon, you might also want to consider industrial PCs, because Movicon is software and you need computer hardware to run it on. And your wider application may also include switches for network connectivity, as well as power supplies to drive the IPCs themselves. But the key focus through this session is going to be on connectivity using OPC UA, and particularly the HMI SCADA functions. So what is Movicon? The easy way to describe Movicon is as a flexible, scalable, automation and industrial Internet of Things platform. It gives you a scalable modular platform for any type of connectivity or HMI or SCADA project. And it also provides the industry's most innovative and flexible software platform both for IIoT and HMI projects, SCADA systems, and it also extends to plant analytics and edge computing solutions. Movicon supports data collection, operator supervision and control, and management reporting. And with Movicon, we have over 30 years market presence and over 150,000 nodes installed worldwide. Movicon achieved Control Engineering's Product of the Year Gold Award in 2023 for its innovative capabilities, as well as its very good graphics and its good data collection capabilities. Now, looking at the diagram here, you can see some of the components of Movicon. So if we start on the left, we have Connext. Connext is an OPC UA protocol gateway. So its key purpose is a set of multiple PLC drivers, not just for Emerson PLCs, but also for competitors' PLCs, as well as other protocols, such as BACnet, being able to talk to SQL databases, MQTT, and so on, and OPC UA as well, of course, both as a server and a client. So OPC UA protocol gateway is the main purpose of Connext, but Connext can also log data into a database, and it also has alarming capability. So it already fulfills some HMI SCADA functions, but without the visualization. If you want visualization, we move along to the right, and this is where Web HMI comes in. So Web HMI is a machine or IoT-based HMI using web-based visualization. So it has all the features of Connext, but it also adds on visualization using a web server, and to display the graphics you would use a web browser. So a standard HTML5 web browser, and you can display the machine data, you can display things like reports, recipes, and all of the other aspects that Web HMI gives you, all using a nice, easy to use interface. And it's not just about viewing data, it's also about writing set points back to the PLC to allow the operators to control the process. Now, Connext and Web HMI are also included in our package solution, so you can see my separate slide deck on package. And package covers additional functionality such as the industrial computer, as well as standard commercial off-the-shelf open source software to provide edge computing, analytics and machine learning. And the idea of adding Connext to package, adding Connext gives you additional protocols over and above what the standard functions of package would support. And adding Web HMI gives you all the capability of Connext with its drivers, as well as the ability for a local web-based HMI solution. Now, Connext and Web HMI are cross-platform. They will work on Linux and Windows. And then moving along to the right, this is where we have Movicon Next, which is our full Windows-based HMI SCADA. So this uses .NET from Microsoft. It uses the latest Windows Presentation Framework graphics, and it gives you the greatest capabilities and the best performance for standard HMI and SCADA applications. We have augmented reality for an immersive experience. Movicon Next also supports a web-based and mobile visualization, so you can use a HTML5 client, but it also supports iOS, iPad, Android and Windows native clients to be able to do visualization on tablets and portable devices. And then we can extend Movicon Next further with lean manufacturing and energy monitoring using the Pro Lean option and the Pro Energy option. And we'll be talking more about all of these aspects as we go through this deck. A key feature of Movicon is platform scalability. It uses a client-server architecture for flexibility, and we can scale from 50 I/O tags to 1 million plus I/O tags, and from 1 to 1,000 users using a variety of different client types. Movicon performs connectivity, and what it does is it collects data, and it can also function as a machine-to-machine and IoT gateway. And the way this works is that when you create I/O tags, each I/O tag can have 2 PLC addresses, and data from one PLC can automatically be transferred to the other PLC and vice versa. So very straightforward use and configuration for machine-to-machine applications, as well as gathering data and then making that data available to other applications. It then functions as a HMI from a machine level as an operator interface, but all the way up to an enterprise level SCADA. By collecting, controlling, displaying and analysing data, we can give the operators the capabilities to understand their operations and to control their machines. We have alarm and events to ISA 18.2, and we can extend this to include maintenance and analysis and notifications, including sending emails, sending SMS messages, using instant messengers, and even sending voice messages using voice over IP. It also supports integration from other systems with a variety of interfaces. So for example, we have a CCTV viewer, we have database viewers, and we have scripting capabilities to allow us to integrate information from other systems and display it all in a single user interface to the operators. Now with Pro Lean and Pro Energy, this gives us the option for energy and efficiency analysis. And with built-in database logging and reporting, there are lots of functions there for management reporting type capabilities, as well as being able to support various applications for the plant. Remote access is supported. We've got web and mobile clients, and we also support virtualization and cloud integration, so you can run Movicon in the cloud if you want to. You just need to make sure that you've got enough bandwidth in order to be able to support all of the data requirements. So here's a typical architecture. You have your Movicon HMI SCADA server in the middle. They can be simplex or redundant, and we have an N+1 redundancy arrangement that I'll talk more about later. You can have a database. The database could be a standard SQL server, or we can do SQL Azure in the cloud, or we can do MySQL or Postgres, and there's a variety of different databases we support. Again, we'll talk about that later. We have user integration with Active Directory and domain servers. So that gives us very good levels of security. And then we've got all of these different client options. So there's an engineering workstation for development, And then we have a variety of different operator station capabilities using a runtime client or a web client. We have the remote clients, web or mobile. We can integrate with the cloud. And of course, we can connect onto the PLCs, and with the controller network, we can integrate directly with PLCs and I/O and with other devices. Now, redundancy is optional, and it is possible to combine servers, so you can have a simple system with a single computer that includes both the server and the client, all the way up to a multi-user, multi-computer distributed application with virtualization and cloud-based operation that can support multiple users across your entire enterprise. A factor that Movicon excels with is its graphics capability. We have very good, up-to-date, high-performance graphics using the Windows presentation framework, and this means that you can create extremely comprehensive and attractive looking screens, which allows your users to fully understand what the machine they're controlling does. This is very important because we have a concept of affordance, and the idea of affordance is that the more something looks like or represents what it's actually doing, the easier it is for operators to learn and understand and operate the equipment, and the less likely they are to make mistakes. This is also important for new HMI SCADA projects because it means that training for operators is reduced, and also for upgrades of legacy SCADA projects. Again, if you don't have to provide too much training for your operators, then it means that they can switch to the new system a lot more easily. Another aspect of attractive looking graphics is for OEMs. If you've got nice looking graphics, then this means that your whole machine can look better and look more professional. So imagine you're on a trade show, you're looking around lots of different machines which are very, very similar in what they look like. If you see a machine that's got a better specified human-machine interface or operator interface with much nicer graphics, and there's not much else to choose to between machines, then it's likely that you as a buyer would go for that machine with the more attractive graphics. So it can also be a very big differentiator for OEMs as well. So using the Windows presentation framework, we have scalable graphics, so we can scale across multiple resolutions, even though we only have to develop a single time. We've got vector-based graphics supporting both 2D and also 3D capability. We also have DirectX support and hardware acceleration, and this is important because a lot of modern processors have graphics processing units, and being able to take advantage of that GPU means that we can reduce the load on the CPU, and that can improve overall system performance. In order to create graphics, we support a rich set of dynamic animation functions. So this includes movement, colors, scaling, transparency, all the aspects you need to create very attractive looking graphics that represent what the machine or process is doing. To simplify configuration, there is a centralized symbol repository with a rich library of pre-configured symbols and objects. And this means that if you want to do things like buttons or lights or even more complex objects, those graphical objects are often already pre-created for you, so that saves development time. If you want to modify our symbols or create your own symbols, that's also possible as well, so you can create your own library of objects according to the projects that you need to do. We also have 2D and 3D graphics import of XAML files, and this means that if you've got many other common formats out there, you can convert to XAML and import them. We also support direct import and display of BMP, GIF, JPEG and so on in order to display graphics very easily. For the screens themselves, we support styles and screen layouts, and this reduces the amount of configuration work required. So for example, with screen layouts, you can have common areas for menus and for titles and for navigation, and that means you only need to create those once rather than have to create them multiple times across every single screen. It also means if your menu hierarchy changes for whatever reason, then again you only need to modify that once. You don't need to update it on every single screen. We have full support for multi-touch functions, so that includes pinch and zoom, it includes swiping gestures, single, double and triple tap, so all of those gestures are supported to allow intuitive operation when your computer device has a touchscreen. Touch manipulation functions are also available for objects, so again, users can control the objects in terms of their operations and set points in very intuitive ways without having to learn special techniques, and also in the same way that many people are used to using standard mobile phones and tablets. This also makes the system more attractive in use for younger operators who are used to these multi-touch type operations. Now, as well as supporting all these swiping gestures for navigation, we also support the Windows Tile interface. The Windows Tile interface allows us to create a default menu without any work. So when the system first starts, instead of a main page, what you see is a list of all of the screens. And for simple development and for many applications where you don't want to have a complex menu structure, this simplifies development of the screens. Also very good for prototyping because you need to do minimal configuration in order to be able to configure your screen hierarchy. We also have a GeoSCADA mapping option. GeoSCADA allows us to map onto Bing, or these days Azure, or OpenMaps. So the idea there is that you can have a map on the screen and then you can see your objects overlaid on that map. Now this supports a variety of different mapping modes, including satellite and road maps. We also support multiple zoom layers, so as you zoom in and out for the map, then what you can see is increasing detail for the objects, and the objects on the map can be animated and they're positioned according to their GPS coordinates. What it also means then, as you zoom in, you can have more and more data. So at a high level you might have a simple icon showing that an asset is there. As you zoom in, you can change that icon to show more detail, including running, stopped and fault states. And then what you can also do is you can then enable the operator to be able to click on those icons and then open up a more detailed view to allow them to monitor and control the asset. And as we've seen in previous pages, these graphics are also available using web clients and also using mobile clients, and we also support things like RDP and terminal services as well. So this allows you to create powerful and versatile graphical interfaces and animated screens using Movicon. So in order to see what Movicon Graphics looks like, I encourage you to go to the Movicon Software Experience Hub, and there we've got multiple videos of sample applications. And the other option is to download the trial and you can run Movicon on your desktop. We have multiple industry demos, including marine, factory automation, process automation, and this allows you to see all the capabilities of Movicon, including the scalability and the 2D and the 3D graphics capability and the GeoSCADA capability. These sample applications also include other functionality such as alarms, reports, recipes, and all of the other functionality that's available with Movicon. So now we're going to take a deeper dive into some of the technical details of Movicon and how it's installed and how it works and what requirements there are for running Movicon. So for system requirements, these vary according to what application you're running. Is it Connect, WebHMI or Movicon Next? And also these would vary according to what you're trying to do in terms of the actual application and the amount of tags you have, and maybe the amount of data logging you're trying to do, and also the complexity of the graphics. So Connect with our OPC protocol gateway. This is supported on ARM or AMD x64 compatible CPUs. We recommend a dual core CPU with 1 GHz or better. We recommend 2 GB of RAM for Linux and 4 GB for Windows, and it needs about 4 GB of hard disk on top of all the operating and everything else. Now we do support Linux, and we support any Linux distribution supporting the .NET Core, so that includes Ubuntu, Debian, Raspberry and so on. And Connect is supported on Windows 10 and 11, Windows Server 2016, 2019, 22 and 25. And if you're using the database aspect, we support SQL Server, SQL Azure, MariaDB and MySQL, SQLite and Postgres and Timescale DB. Now WebHMI is very similar, but with WebHMI we're adding on this web-based visualization, so that means you need some additional computer resources potentially in order to be able to run the web side of things. But in principle, WebHMI and Connect have the same core requirements, but you might need additional requirements if you had very complex graphics or large amounts of data logging and so on. Now when we move up to Movicon Next runs on Windows. So now we no longer have ARM support, but we can run on AMD and Intel x64 compatible CPUs. I recommend a much faster CPU, so the minimum specification would be a dual core 2 GHz CPU, but I'd recommend quad core and 3 GHz or up, which these days is pretty much what you get from a standard computer anyway, although it could be that some older and embedded type devices might not have the performance you need. But a modern industrial PC should run Movicon Next with no problems. The minimum is 4 GB of RAM. I recommend 8 GB or more, and 16 GB is preferred. RAM isn't too expensive right now, so it's a good idea to buy as much as you can, although I do see that RAM prices are increasing. But even then, RAM is only about 10% of the overall system price, so the more RAM the better. Again, for a typical application, you're looking at 4 GB hard disk space on top of the main operating system, but you might want more if you're doing a lot of database logging, so that will depend on what your database requirements are. Now, because Movicon Next is Windows based, we're supporting Windows 10 and 11, and we're supporting Windows Server 2016, 2019, 2022 and 25, and it's the same range of databases we had before. So SQL Server, SQL Azure, MySQL, MariaDB, SQLite, Postgres, Timescale DB. And in principle, with the database side of things, it's any database that has an ADO connection string. So we're using XPO providers. So you can have additional databases, but in principle, we cover the majority of standard databases out there. And if you're talking to a more time series database, or maybe it's a database in the cloud, then that might use other protocols, possibly OPCUA, possibly MQTT, and those protocols are also available in Movicon. Now internally, Movicon Next runs as a set of services and applications on top of the operating system. So the core part is the I/O data server, and this is our automation platform based on Microsoft's .NET technologies and extensively using OPCUA for internal communications. So this is a very modern architecture. This was developed with Movicon 4.0, which was introduced in 2020. So although Movicon has been around since the early 1990s as an application, Movicon Next version 4 is using this brand new architecture, and we continue to update this to use the latest .NET technologies as Microsoft introduces new versions. The benefit of using .NET is it reduces some of the work that we have to do, and it means that .NET gives us a good platform to run on. The other benefit is that .NET opens up potentially cross-platform operation, because .NET is supported on other platforms besides Windows. So for example, for Connect and Web HMI, .NET enables us to run on Linux. And also .NET, as each version comes along, you get improved cybersecurity, and what you also get is improved performance. And of course, computer performance improves from year to year anyway. Intel are making fantastic strides with their processors, as are AMD. So that means that each year goes by, performance gets better and better, even though the applications themselves are growing in size. So the core is the I/O data center. This is really where all our communications occurs. So the I/O data center manages the I/O data tags, it manages alarms, it manages historians, and it manages all of the alarms. So this is the core of the application that's managing the data itself. Underneath the I/O data server, we run the I/O drivers. So there are multiple I/O drivers for PLCs and other industrial drivers. So that includes standard protocols for Emerson PLCs, including OPCUA and Modbus RTU and Modbus TCP. We also have other I/O drivers for our competitors' PLCs, and we also have I/O drivers for other protocols. So there are telemetry protocols, including IEC 61850 and IEC 104. We've just added DMP3 as well. We also have drivers like MQTT. We have drivers for things like BACnet. So there's a wide range of protocol drivers available to talk to many different devices. Now above the I/O data server, here we have the OPCUA information model, which is part of the networking side of the system. And on top of that, this is where our clients fit. So we have a runtime client, and the runtime client gives you the best performance and the greatest capabilities because it's based on the Windows presentation framework. So that runtime client supports 2D and 3D vector graphics, and it supports GeoSCADA, as well as all of the normal graphical functions that you might need for a HMI SCADA. As an option, we also support web and mobile access using HTML5 technology. So you can use a HTML5 web browser to be able to display data using Movicon's built-in web server or using Internet Information Services. And then we can also have mobile clients as well. So they use that same HTML5 technology, but now we have an actual client running on iOS or iPadOS or Android or Windows. And the idea now is that this can use a built-in web server, and this can give us again a higher level of graphics than is maybe capable using just the raw web client. Because the web client is using a combination of CSS and HTML5, and it also uses JavaScript to render graphics. Whereas with the clients, they can use native technology based on whatever the client is running. But it does give you multiple options for your clients. Runtime clients is preferred, but then we also have those web and mobile clients. Now, alongside the I/O data server, there are multiple other applications included. So one is a scripts manager, and with the scripts manager, we have a VB.NET scripting engine along with supporting schedules and events. So with the scheduler, you can perform actions on a regular time basis. With the event manager, then you can run events at a certain time, and those events might be perform some action, such as make a set point or upload or download a recipe, or they could be to run a VB.NET script. And with version 4.4 of Movicon, we've just added Python scripting support as well. So that gives you another language capability. VB.NET is well known in the HMI SCADA industry, but many people consider VB.NET old. And if you look at what most engineers are learning today, it's Python. So that gives us more capabilities and another option for newer, younger engineers and people who've had recent degrees who might want to prefer Python rather than VB.NET. We also have an alarm dispatcher. This allows us to send alarms via email, SMS, voice over IP and instant messenger. So this is another way of getting alarms to users. So of course you can put alarms on screens. You could also have an alarm that runs an event and maybe performs some action, but you can also send those alarms to operators via their mobile devices. Even if they're not actually connected to a HMI server using a client, they can still get that alarm information. We also have a recipes manager. The recipes manager can coordinate with a database to upload and download recipes from the database. There's a screen manager to allow you to manage the recipes as well. You can also manage the recipes through scripts and other aspects on the screens. And then of course the recipes can be downloaded to the PLCs, so you can associate the recipe elements with the PLC IO tags, and then you can download that recipe to the PLC. It's also possible to upload recipes from PLCs as well, in case any user made a change in the PLC, so you've got very comprehensive recipe management. So generally, HMI SCADA is concerned with real-time data, which is the data that's actually in effect at the time, but many applications also need access to historical data. So we have multiple options for data logging and analysis. So we can data log to a variety of different SQL databases, and we can also support data presentation using a data analysis object, and we also have trend objects and grid objects. So you can bring historical data onto the screens and allow users to display that in multiple ways, both tabular and graphical. And also, once the data is in an SQL database, it's also possible for an external application to manipulate and display and use that data as well. Another thing we have is built-in reporting, and reporting allows users to create either ad hoc or scheduled reports, and those reports can be displayed on the screen, or they can be stored to a file address, or they can be emailed to users. So reports could cover shift reports, end of batch reports, ad hoc reports, maintenance reports. And the idea of the reporting application is it takes data from the SQL databases, or it can also take data from the current IO tag database. So you can get a combination of current and historical data being displayed in your reports. The reports manager again is very comprehensive. It allows you to have sections and pages and headers and footers. So very comprehensive reporting capability and output in multiple formats, including HTML5, Excel, CSV type formats and PDF formats. Now, modern applications need good cybersecurity, so we have built-in security, and then we also have the option of Microsoft Domain and Active Directory integration, and we can use other security providers as well, but most users are using Microsoft. So the idea there is that you can create users, you can assign users to groups, and then those groups and those users can have different priorities within the system. So you can allocate access to screens and objects based on usernames, based on user levels, so that there's like 0 to 1,000, and the higher the number, the higher the access. And you can also allocate users to plant areas. So there's lots of capabilities there to have security and distribution of alarms and restriction of access to screens and so on, based on all of those different user objects. Movicon also has some other capabilities. We have multi-language support. So when you create a screen, any screen object has a text item associated with it. And what you can do with those text items is you can create multiple columns, and then you can have different texts for different languages. So you could easily then translate in runtime from, say, English, Italian, German, other languages, and we even support left to right and right to left languages as well. So the idea is that your users can configure on the fly to switch between those different languages. And that's very straightforward to support because that's automatically created by the graphics. You just need to do the extra work to go in and add the extra languages and do the actual translation. Now the IO data server, that can also be redundant. So we do have this N+1 redundancy where you can have one or more backup computers. Two reasons for that. One is you might want better resilience than just having two computers with hot standby. So you can have hot standby +1 or +2 or more. The other idea there is that when you have clients, the clients are distributed across the available servers. So if you just had two computers with a lot of clients, if you have one failure, you would have up to 50% of your clients suddenly transfer over to the backup server, and that could cause a big load on the system. So by having additional backup servers, that reduces that stress when a main computer goes down or is turned off for maintenance. So lots of powerful capabilities using Movicon Next Server architecture. Many of these capabilities are built in, a few are optional extras. So for example, redundancy, that's an optional extra. Reporting is built in, multi-language is built in, recipes is built in. And on the protocol side, the IO drivers, there are different protocol families, and some of those are optional extras as well. So you always get OPCUA and Modbus TCP, and then some of the other protocols are add-ons. So for example, we have like a facilities pack for BACnet and so on. We have a telemetry pack for some of the other protocols, and they are optional extras. The alarm dispatch is an optional extra, but things like scripting and many of these other capabilities, a lot of those are built in as standard. So here are some more details of the Movicon Next HMI SCADA platform capabilities. So we've mentioned IO drivers. We have multiple IO drivers for PLCs and industrial devices. And there's a possibility for each IO tag to be connected to two different devices to allow HMI SCADA machine-to-machine type capabilities. So very good as a machine-to-machine or M2M gateway by having same tag with two different devices. The idea is if any one of those tag values inside one device changes, then that data value is propagated to another device. So that gives you that gateway capability with very simple configuration. And you could also have more than two different devices connected because you also get OPCUA server capability up to a higher level, as well as the ability to manipulate that tag in other ways through the application. Now IO tags, they could be simple tags such as Boolean or integers or floating, but we also have support for complex data, we have support for parameters, and we have support for structures. So there's ways there to represent more complex data values rather than just a simple data value. On the IO data server itself, we do support OPC-UA client and server capability. OPC-UA client gives us very good security capabilities, including support for certificates, for signing and for encryption, and on the server side we have that as well. The alarm management, that is compliant with up to ISA 18.2, so we've got things like acknowledge, reset and shelving configuration. The alarms themselves support chronological recording, and the accuracy is down to millisecond accuracy, so that allows you to do things like first up alarm analysis by working out which alarm came up first, down to a very high level of accuracy. There's also the ability to add comments, and you can also audit the alarms as well. And then we've got that alarm and event notification option using SMS, email, voice and instant messages. There's also an option for statistical alarm analysis. This gives you like a Pareto capability, so you can do top 10 alarm occurrence, top 10 alarm by duration, and there's other capabilities in there. And this is a very common requirement for continuous improvement and Six Sigma and Lean type applications. So without having to buy an expensive option or doing a lot of configuration work, that statistical alarm analysis, it gives you predefined alarm reports which give you that Pareto type analysis to allow you to work out which are your most costly alarms, which are the ones that cause the most downtime, and then you can work on those to improve your operations. Now for life sciences and nuclear applications, we do have an audit trail which is certified up to FDA 21 CFR 11. This gives you user authentication management, and it also gives you full traceability of any tag changes for auditing purposes. For scripting, we have VB.NET and Python scripting. And also for some applications, you might not want to use a complicated scripting engine, so we also have a graphical function block diagram logic engine as well, which also supports JavaScript for simple applications. For the historians and data loggers, they can connect to any SQL database. So we've got integrated support for SQL Server, SQL Cloud Azure, MySQL, MariaDB, Oracle and Timescale DB or Postgres. And we also support any XPO type data provider by creating a suitable connection string. Now we have a choice of both historians and data loggers. Historians store a single value per record. Data loggers can store multiple records. So data loggers are preferred for where you're going to be doing trending, because in principle that gives you more efficient data recording. But historians, they give you more accuracy, including better compliance and traceability. But you can use both of those options, and you've got very efficient data recording, and you've also got support for data aggregation as well. So one of the issues with HMI SCADAs, if you're logging lots of data, you can very quickly fill up the database. So data aggregation, what that does is on a timed basis, it eliminates older values and it aggregates those into a smaller set of values, such as minimum, maximum and averaging over a specific period. And then you can delete all of the raw values and you can just use that aggregated data. Again, we have FDA 21 CFR 11 compliance for the data. And we've also got support for automatic redundancy and multi-server configurations. And another option as well is if the historian or data logger database is on a remote computer, we automatically support store and forward. So if there's any problem with the network or any problem with the database server, then we support local logging of the data until the network or the database recovers. Now recipe management is built in. I mentioned that on the previous slide. Lots of capabilities there to upload, download, manage recipes. We've got very good cybersecurity with IEC 62443 certification. And again, with that user management, you can either have a centralized management system using Movicon security, or you can integrate with Microsoft Domain or Entra or whatever your security provider is. We mentioned multi-language support. We have that. We have reporting, trending and analytics capabilities. I mentioned redundancy, but we also have virtualization support. So Movicon will run very nicely in virtualized environments on virtual machines, and that includes running Movicon in the cloud. So as long as you've got the required bandwidth and computer performance, we don't really care where Movicon runs. You just need to make sure you've got enough performance, and Movicon will run nicely in any of those applications. And then with the variety of different applications we have available, including scripting and database integration, we've got very good support for integration with third-party systems. So, for example, your AMS, LIMS, maintenance systems, MES, ERP. So there's lots of options there for integration with third-party systems. Another aspect of that integration is on the graphics side. We have a very nice video over IP system, and that allows us to embed CCTV images directly into Movicon. So you don't need to use separate applications. You haven't got any issues around performance there. We do support that video over IP directly inside Movicon screens. Movicon includes a comprehensive reporting package. For many users, they will be relying on these screens to display data, but what you can also do is create reports and distribute the reports to users. So reports generally focus more on historical information, but it can include current information as well. Reports can be simple or complicated, and we support tabular and trend reports, and you can mix and match different types of data, and the tables can be displayed in multiple formats as well. And we can also display trends and also other objects such as bar graphs and pie charts. There can be color coding. So you can get very sophisticated reports that can give your users a lot of information about what's going on. So that might be a shift report, might be a batch report, it might be a daily report or a weekly report. So there's lots of different reporting options there, including the abilities to have graphical elements. You can also customize the report with the user's logo or their corporate functions. You can also have different font types and so on. We can do grouping, we can have custom headers and footers, we can have subgroups, and you can also have summaries as well. So a lot of very clever reporting applications. The data itself comes from either a SQL database or from the tag-based database and variables. And there are also predefined reports. So some of those predefined reports include alarm summaries, but you can also do ProLean, which gives you OEE reports, and ProEnergy, which can give you energy reports. So those are the optional add-on modules with additional information. But very powerful reporting, and it's built into Movicon at no extra charge. So that's very interesting, because with a lot of competitors' HMI SCADAs, reporting is either an external add-on from a third party, or if it's built in, then it's normally an optional extra that can be quite expensive. But Movicon has built-in reporting at no extra cost. For energy efficiency and plant analytics, we have these optional modules. So ProEnergy is an energy efficiency software solution. And what ProEnergy allows you to do is monitor multiple energy sources in real time and also historically. So we support mainly electricity, because that's what most people are concerned with. We can bring in data from electricity meters or from the PLCs that they're connected to. But we can also support gas, water, steam, air, chemicals, etc. And what Movicon's ProEnergy can also do, based on the tariffs for these particular options, we can also include cost information. So that's very important these days, because electricity isn't always purchased at a standard price. There might be a variable price, and we can have variable tariff support. And the reason that's important is when energy is cheap, rather than saving energy, you might want to be using more energy. So if electricity is cheap, let's increase our operations, take advantage of that low cost of electricity. First of all, that allows you to improve your throughput without increasing your costs. But also, when energy is cheap, generally that means there's an excess of electricity on the grid, and what you're also doing there by using more electricity is you're helping to balance the grid by using up the extra electricity and by avoiding curtailment of whatever your energy sources are. For example, if it's a sunny, windy day, then wind turbines are running, solar power is running. That tends to be very low cost, but also very green electricity. So if you can take advantage of those low electricity prices, you're also performing a sustainability action there as well. So very important to have the cost information, not just the raw energy usage. So what ProEnergy allows you to do is understand your energy consumption and the costs, and that helps you determine how to implement cost reductions, and of course that results in increased efficiency and sustainability. Now, ProEnergy doesn't do all the work for you. It gives you the data, but that data is important then to actually drive your efficiency improvements and sustainability. So for example, you might look at energy per machine, and you might see that some machines use more energy than others. So you could consider using those machines less often, or maybe those machines need some sort of retrofit or update in order that they can reduce energy efficiency. But again, without the data, you don't know. So this is the whole point of ProEnergy. It gives you that data to understand where your energy is being used. So to configure ProEnergy, you've got a nice wizard-based approach. There's about 10 wizard steps, and they go through creation of the different tariffs, the energy sources for your meter data, and then the result is you get predefined calculations, key performance indicators, and it automatically creates dashboards and reports for you, which means you can be up and running very quickly. You can run that wizard in just a few minutes, assuming that the underlying data is available, and you can typically be up and running in as little as half a day, and then that starts giving you that energy information that you can then use going forward. Now, the predefined calculations, KPIs, dashboards and reports are usable for many users, but if you do want customization, then it is possible to customize that. So you can either add your own dashboards and reports, we give you the data, and we give you the objects that you can use to create your own specific user implementations, or you could modify our existing ones, but you've got full customization there if you want to. We've also got ProLean. So ProLean is a plant analytics software solution, and again this allows you to acquire production data in real time and then understand and calculate overall equipment effectiveness. So overall equipment effectiveness includes three aspects. So the first one is availability. Is your machine running when it should be? The second one is performance. Is your running machine as fast as it could be? And the third one is quality. So they're the three underlying aspects of OEE. And the top line is a value, is a percentage, which tells you how effective your machine is. So for a typical discrete type machine, world-class OEE would be in the order of 85% plus. Anything between maybe 75 and 85% is good, less than 75%, and that probably means that you need to pay attention to your machines. But even small percentage improvements can make a big difference in terms of the effectiveness and the reductions in scrap. So what you can do is you can look at the top level OEE number, and then you can drill down, and then you can look at your underlying OEE. So for example, your availability might be high, your performance might be high, but if your quality is low, then you're having quality issues, and that's where you would devote your time. So again, the idea is that by having that data, that enables you to understand where the problems are, and then having an understanding of that allows you to go forward and make changes. And this is all based around lean techniques, Six Sigma and other quality initiatives. And when I used to do Six Sigma, we used to use the DMAIC process. So that's define, measure, analyze, improve and control. Define starts off when you have a problem. And one of the ways of having that problem is to look at your data of your machine. Another way is to respond to maybe customer complaints. Maybe you're getting quality issues and your customers are complaining. But you define the problem. The next step is measure. So that's where that data analysis comes in. And one of the aspects there is you need that data. So you could start measuring straight away. But often, if companies already have that data in their systems, then that measure phase can be much faster, and then you can move straight to analysis and improve. And then, of course, you need that continued data for the control part to make sure that you have a continued effect. Sometimes people implement changes, and then there's a revert to the mean because those changes aren't being pursued, or there's other issues, and you end up with those changes not being as effective as they could be. So you need that complete DMAIC process. And if you have that data as part of, say, an OEE, but also maybe in an energy efficiency application, then that measure phase can be very fast. So the more data you've got, the better it is you're able to take decisions and make changes. And then of course you need that data to be able to control the situation. So ProLean uses a similar wizard-based approach. It allows you to configure, and then with the wizards there's a few more steps because you've got a few more data items, but then that gives you your calculations, your KPIs, your dashboards and reports, and again very fast implementation and return on investment. Now with ProEnergy, a typical data item is just one data value. For example, for electricity, your core that you're looking at is either kilowatts, and then we can convert kilowatts into kilowatt hours by integrating over time, or maybe you get a kilowatt hour value, and that's a single value from your meter. Gas and water, that might be meter cubed and so on. With ProLean, you're looking at a few more data items. You need to know when the machine is running, you need to know when it's stopped, you need to know the number of units you're supposed to produce and the number you have actually produced. So there's about 7 data items you need as a minimum, and there might be additional downtime reasons as well. So you need at least 7 data points. So there's a bit more configuration required for ProLean, and there's also a bit more planning required. But again, you do have a fast return on investment. You can configure ProLean within 1 or few days, and you can be up and running within a week and start collecting that data and then producing the OEE reports. So very fast implementation and very fast return on investment. Again, fully customizable for specific user implementations. We provide the data formats, the reports and so on, and the underlying objects. So if you want to build your own graphics or modify our graphics, then that's entirely possible. But these are very good add-ons, without going to a large amount of money for a manufacturing execution system or to configure some bespoke energy efficiency or plant analytics application. These are very good add-ons to allow Movicon to perform those functions. And that's often a preferred approach anyway. In many cases, the data is already there in the PLCs or the machines. And if it's in the PLCs and the machines, you can then easily get that data into your HMI SCADA software. And again, in some cases, the data is already there in the HMI SCADA software because people have already configured the data tags for it. So it can be very quick to implement energy efficiency and plant analytics as part of your HMI SCADA. And again, you can start getting very quick results by using this simple wizard-based approach and then developing your screens and reports and enabling users to access those very quickly. Let's take a look at some Movicon architectures which you might employ for different sized applications. Here's the architecture for small applications. In the middle, we have a computer, could be an industrial computer, and that computer would run all the software you need for your application. So that could include your SQL database, it could include your reporting server, it could include all of the HMI, of course, and that also serves graphics to a local user interface via a local monitor. And that could even be a panel PC, so where you've got the computer and the monitor integrated all in one device. So you've got the communications down to your controller network. So that would be typically Ethernet, although it could be serial or maybe even some other protocol. And then there's an optional connection via a firewall to remote clients, which could be web or mobile. That could also be an integration into your alarm dispatcher. And then there's another optional connection up there to an enterprise network, so you can support your cloud and enterprise applications. But effectively, everything on the right there is optional. A very simple application would be as simple as a single computer running the required Movicon software along with any other software that you need. For medium to plant-wide applications, you've got that same central computer. This is over on the left-hand side now, and this can be an integrated device running all of your HMI SCADA and SQL database applications, or they could be on separate computers. But for many applications, it can be a single computer. So again, you've got your controller network, and that communicates with your PLCs and I/O. You've got the HMI SCADA server running Movicon along with the database, And then above that, you've got a network to support a number of connected clients using our runtime client. So this could be one or more computers which are now distributed over the HMI SCADA network. And again, for a small application, that might be all you need, but you can extend that with a firewall to connect to remote clients, such as web or client or mobile clients. You can have an optional external SQL database, which could be on-prem or even in the cloud. And then optionally on the enterprise network, you've also got your domain server for user management, as well as your connection up to your cloud or enterprise networks. So it's very scalable. You could just have the items just on the left-hand side, and then you can extend outwards onto the cloud or enterprise as required. But the basic architecture can be very straightforward. For redundant applications, it's effectively the same architecture that we saw before, except now you have an additional computer for redundancy. So we do support N+1 redundancy, but in a basic redundant application, and this is for most applications, it's 2 computers. So a primary server, which is normally your master, and then you have a backup computer. The backup takes over when the primary fails, or more likely these days, if the primary is power cycled after installing some sort of operating system update. This can also be used where you maybe want to do application updates, such as increments to the Movicon application or to other applications. Maybe you're updating the database server, for example. But very simple, we've added an extra computer, and now we have that additional level of redundancy. We do support redundancy at the controller network level. There's options there for multiple different network options and redundant PLC options. And we also support redundancy at the HMI SCADA network level as well, typically using redundant network implementations based on STP or RSTP or similar. And then again, on the right hand side, you've got the same as we saw before, with the option for remote clients, an on-prem or cloud-based SQL database server, and the optional domain server for user management, along with whatever other integration you might need. Again, remember reports can be sent by email, so you would need access to an email server to send those reports, and that would be part of the enterprise or the cloud solution. But again, very simple architecture for redundant applications. We've just added 1 extra computer, but we do support N+1, so you could potentially have up to 4 servers with a main server and then up to 3 backup servers. But for most applications, it's 2 computer servers like we see here. For large applications and distributed across enterprises, what you can do is you can have multiple sites. So each site would use one of the architectures we saw before, and then you would have a wide area network or cloud network, and this is where you would be able to consolidate all of your data into a central control room. So again, choice of local simplex or redundant HMI SCADA servers along with all of the database servers. You could have local clients connected via a variety of different network options, and then you've got that wide area network up into the central control room. And then the central control room is typically where you'd have your engineering workstation for your development, along with your centralized operator workstations. And there's a variety of different ways we can do distribution of data. We can use child and parent projects, which allows you to have multiple projects which are linked together. We can have independent projects communicating via OPCUA. Or another possibility that I see in a lot of these larger applications is each site has its own computer SCADA server, but rather than having a SCADA server at the central location, what that's doing is coordinating data using the databases. Because often by the time you've got to the central control room, you don't care whether the data is actually in real time or not. If it's a few seconds old or a few minutes old, and often, of course, you're doing analysis over older legacy data anyway using the database, so it could often be that your central control room is coordinating using data from the databases. So that might use some sort of more reporting type application rather than a dedicated HMI SCADA application. So there are multiple options for these larger applications, but the architecture typically looks like this with multiple distributed computers. And again, you've got the option of redundancy, and you can distribute your databases, and you can also have the multiple clients connected in multiple locations, and you've still got that support for cloud and enterprise integration as well. Now going back to these very small applications, this is what your HMI architecture look like if you're using Movicon as an opera interface type application. So these applications typically have a single computer, such as an industrial PC or a panel PC. You'd have your connection to your field devices. You'd run your Movicon Next server, and then you'd have the runtime client, and that's available as a single license. So we have the RTCS4 license, which includes the client and the server all in one system, all in one solution for installation on a single computer. And then there's again the option of that local database, but that database could also be on-prem or cloud-based. And remember, we support automatic store and forward. So if that database was remote and there was a network connectivity or database issue, Movicon would store the data locally until the database recovers. You can have additional clients, so you can network and you can have clients which are based on either the runtime client or a web client or using a mobile client. And with this one, you'd have a separate development computer, and then you would deploy either by copying files from one server to the other, or we do have a deploy server option as well, which is more of a distributed type approach for deploying applications. But again, very simple architecture for single computer operator interface type applications. And it's effectively the same architecture for Web HMI. The difference is that with the Web HMI server, you're now using a web browser as the client. So again, that could be on one computer, but you've also got the option of using additional clients running HTML5 browsers. And then this time you do deploy via the deploy server. So there's no file copy option. Instead, the development computer runs a deployment client and you deploy to the deployment server that's running on your industrial PC or panel PC. Now, the benefit of using the Web HMI is that your industrial or panel PC doesn't need as many computer resources, because Web HMI tends to be a lot lighter than the full-blown Movicon Next, mainly because of the WPF graphics, the Windows Presentation Framework. But the other thing about the Web HMI server as well, we can also run on Linux, and by running on Linux, this allows us again to have a lower hardware footprint, but still have good efficiency and effectiveness. However, the Web HMI can't do everything that the full Movicon can. Yeah, there are some restrictions, such as, for example, Web HMI doesn't support 3D graphics, but it does support the majority of other graphics. And there's a few other restrictions as well. We do continue to enhance Web HMI though, so I would recommend consult the latest documentation on the Software Experience Hub to see what the restrictions with Web HMI are and if they affect you, because Web HMI can be a very good solution for smaller machines. And here are some Connext architectures. So Connext is our OPCUA data server, and the idea is if you don't need the visualization part, you're just interested in getting data out of machines, this is where Connext comes in. So you can use Connext as an OPCUA server, so we can take data from field devices, PLCs and I/O, we can bring that into the Connext server and then make it available via OPCUA using the data access specification for OPCUA. So that's ideal if you've got a remote application such as a HMI SCADA or a database that can do OPCUA data collection, and it can use Connext to convert all those PLC protocols into a common OPCUA protocol. And that OPCUA protocol can also be signed and encrypted using certificates for secure communications. Another option with Connext, which is the next column along, is to use it for data collection. So as well as sending data via OPCUA, Connext can also be installed with an option for storing data using .NET XPO data providers. So this allows us to write to a SQL database that could either be local, on-prem or in the cloud. And remember, we support that wide variety of databases such as SQL Server, MySQL, MariaDB, SQLite, although that would be local only, and also SQL in the cloud, SQL Azure, and also Timescale, which is based on Postgres. You can also have Connext as an alarm server. So in this case, Connext is connecting to the PLCs as before, but now we can serve up alarms using the OPCUA alarms and conditions specification. So this is alongside the data access specification, and now we're using the alarms and conditions specification. So this allows an alarm client to read those alarms from Connext and display the data that way. And finally, you've got that machine-to-machine gateway option. This is where you can have a Connext application running multiple protocols, and then each I/O tag can be configured with 2 protocols or 2 I/O addresses. And this means that whenever one of those PLC values changes, it's automatically written to the other PLC. So very good as a machine-to-machine gateway, and extremely useful because it can be very difficult to connect 2 PLCs with different protocols together. You often need some sort of third-party device, and that device could be one of our IPCs running Connext to allow you to connect via those 2 different native protocols. And you can mix and match all of these as well. So you can combine OPCUA data access, historical data access, a SQL database, and alarm conditions, and the machine-to-machine gateway. Connext will function as all of those in one application if required. Or you could just use one or more of these as you need to. So lots of different options there for using Connext in terms of data collection, OPCUA server, alarm server, and that machine-to-machine gateway. Now the way Connext runs is Connext runs as a service on your destination or your target computer, and again you use that development computer and you deploy via this deploy server. So you develop on one computer and then deploy using a network, and that's how you get your files onto your target machine. Let's investigate scripting. Scripting is a great way of adding additional functionality to your HMI SCADA over and above what the vendor provides. So of course, Emerson provides the standard graphics capability. We provide the ability to read and write databases and put information on screens. We have alarm capability and so on. But maybe you want to do something a bit special. So maybe you want to manipulate the data inside the database. So you might want to do scripting for that using reading the SQL database, doing some sort of transformation and writing back. Maybe you want to do some sort of special algorithm or calculation. So again, scripting might be suitable for that. Maybe you want to do some sort of additional processing of data beyond what you would normally do with the built-in capabilities. So again, scripting might be used for that. And scripting can also be used to handle things like sequences and automated operations, which may be beyond the scope of what the standard HMI SCADA can do. Sometimes as well, there may be automated functions inside the PLCs, but automating those functions in the PLCs needs a PLC engineer. And maybe that's very difficult to do because then you'd be developing in ladder logic maybe, and that might be hard to maintain and debug. So sometimes automatic functions and sequencing might be better performed in the higher level HMI SCADA. Now, of course, you've got to be careful about scripting in the HMI SCADA because generally the HMI SCADA is seen as less reliable than the PLC. However, PLCs, they're very reliable, but these days so is HMI SCADA, and often you need that visualization to be able to control your plant. So I do see many applications these days where some of the automation is moved up a layer from the PLC into the HMI SCADA because it's easier to develop, easier to maintain, easier to control, easier to visualize. So there's no reason not to do that, but you would need to just be aware of resilience just in case that was an issue for you. But in many cases as well, you might have multiple PLCs, in which case it can be difficult to coordinate those multiple PLCs. So again, moving that sequencing type layer one level up is a good way of having coordination between different machines, either in a single cell or even across multiple cells. So lots of options for scripting, including acting as part of the automation system from a control point of view, but also for calculations, algorithms, analytics, and so on. So the basic scripting language of Movicon Next is VB.NET. So .NET does support scripting, and we're using a VB implementation. So VB is Visual Basic. Now, some people say that Visual Basic is a very old language, and you're right, Basic has been around for a long time. Having said that, so have some of the other languages. I think the big benefit of Basic in modern applications is that it's generally easier for operational technology people to understand than some higher level languages. So you haven't got too much object orientation like Java. because that can be very difficult. You need to have a high level of abstraction. You haven't got lots of the memory manipulation and the pointers that you need to use with C or C++. That's extremely difficult for someone from the OT world to understand. Instead, you've got a relatively straightforward procedural language where you can understand in a quite straightforward manner. So it's not the most advanced language. It doesn't have the most complex and advanced data structures, but for OT applications, VB.NET is a very good solution. So inside Movicon Next, there are really three types of scripts. The first is a resource script, and the resource script runs on the server. So because it's server-based, this can affect everyone and everything that's running on the Movicon application. So it's very good for centralized applications. So what you can do, because it's running on the server, you can have that running on project startup, and it can also run on an event, and you can even run that as a service, so it's running in the background of the server, so you don't even need to have a user logging in. It can automatically run as part of your project. So very good for things that need to run at a centralized level and need to run all the time, or that run from an event, and the event can come from any particular client. From an operational point of view, your resource scripts can have full access to IO tag values. They can also, if they've got user level access, they can open and close screens, but that you wouldn't be able to do if you run as a service, or if you do run as a service, you'd have to configure the service as a user level service. So certainly there is some screen possibilities, but normally I would say resource scripts are really reserved to reading and writing IO tag values. What you could also do from resource scripts as well is you can also import libraries, and you can also access system level resources. So maybe you want to do network diagnostics. So you could do like ping commands to determine if the network is running. Maybe you want to read and write a SQL database. Maybe you want to access the computer diagnostics. So that's a good use for a resource script. Now the next level of scripts is screen and screen object scripts. So these run on the runtime client. So these are client-based rather than server-based. And these can run when the screen loads. So maybe you want to do some calculations or read a database when the screen opens. Maybe a user clicks a button and you want to do a script then. So that might be something like, recipe type manipulation, or reading or writing a database on a mouse click. And the idea here is that now these are running on the client rather than on the server. Now a screen has to be open for these to run. So generally that does mean that you do need the user to be present, and they have to have opened up the relevant screen, and that screen needs to be displayed in order for the script to run. So screens and screen object scripts, they've got the same access to IO tags. You can open and close screens, which makes more sense now because you're actually already on the screen. So you might click a button to perform an action and then open some sort of screen. Now Movicon can do this in other ways, so you might not need a script for this, but certainly it is an extra option if you want to do additional calculations or additional work over and above what the normal Movicon operations allow you to do. You've also got access to all the other things you have before. So again, you can include libraries, you can access system level resources, you can access databases. So with the option of including these additional libraries, there's a lot more functions you can do as well. But the key difference is you're running on the client, not on the server. Now the final option here we've got is tag scripts. Tag scripts are defined against tags in the IO data server. So they do run on the server, but they only run on change, or you can have it running like every 500 milliseconds. So there's an option for running there on a regular basis, but it's on a timed basis, and it's about every half a second. So the idea of these tag scripts is these don't have any screen level access. They can only access IO tag values, but these are very useful for maybe when the tag changes, maybe you want to do a calculation. So when that tag changes, maybe you want to run an average calculation and say, okay, the tag value is updated. Here's the new value. Here's the average value. Here's the minimum value. Here's the maximum value. And you could integrate over that over a particular time or a particular number of samples, for example. So yeah, if you're doing something against tags, tag scripts are a good way to do this. Again, you can also include libraries. So by including libraries, you do have access to system level functions. You also have access to databases. So there's a lot of things you can do there in addition to just doing IOTAC calculations. But again, the point to know about these is they are server based and they are focused on tags changes rather than any other sort of operation. But with a combination of these different scripting options, yeah, this allows you to do all of these different applications, and it gives you very good flexibility and functionality, and it also gives you quite a lot of control over where the scripts run and what capabilities they've got available. So very good scripting engine, and within VB.NET, the basic scripting functions are powerful, but you've also got the option to include those external libraries. So again, if you want database access, if you want system level access, if you want to do network diagnostics, yeah, that's available through the VB.NET scripting functions. In Movicon 4.4, we've added the ability to manage and run Python scripts via a schedule, an event, or on a command. So this is an additional scripting option for people that would not prefer to use VB.NET but want to use a more modern language. Now, VB.NET, as I say, is very good for OT type engineers. There's a lot of engineers out there who've been using VB type applications for many years. I'm one of them. I've been using BASIC for, well, I won't tell you how long, it's more years than I can count. It's a long time. So very familiar with BASIC. And of course, the benefit of VB is that VB is used inside Microsoft applications as VBA for applications, and Visual Basic itself has been around for a long time. But having said that, Python is a newer up and coming language, and Python is now the most popular language. So Python, I think if you're familiar with VB, then Python would be very easy to migrate to. And in some cases, Python is easier. You know, its use of white space, the structures it has, in many cases is actually easier and more straightforward to use than VB. And also it's nice and easy to understand. And as it's the most common language, you know, what you find today is that a lot of the younger engineers are probably more familiar with running Python than they are with VB. Another benefit of Python is there are lots of resources out there to teach you Python, whereas with VB, because it's older, it's assumed that people already know it. So Python, because it's a more newer language, you know, there are lots of resources like, you know, how to program, as well as lots of resources on actually solving particular problems. So Python is very good. Another benefit of Python is it's very easy to extend. So there are lots of libraries and references out there. So what you can do with Python is very easily extend it. So again, for things like network access, computer resource access, database access, and even then with Python, you've also got a lot more resources. So for example, web scraping, maybe if you want to do particular data calculations, you know, integration with machine learning, then I think Python has the advantage there, as well as being today's most popular language. So lots of things you can do with Python. You can read and write values via OPCUA, you can read and write databases, you can read and write files, yeah, you can do scraping of websites, you can perform calculations, you can implement that machine learning, and you can implement now those Python scripts inside Movicon, either via a schedule or an event or a command. So it gives you very similar capabilities to what we had previously with VB.NET. They are managed slightly differently, and you have a separate node in Movicon for handling those Python scripts. One of the key differences with Python is that with Python, you don't have a script editor inside Movicon. So you develop your scripts externally, and then you import them as .py scripts. Whereas with VB.NET, we do have a full scripting engine and a scripting editor inside Movicon. But for most Python editors or Python users, that's fine. People are used to creating Python scripts externally, saving those as a .py file, and then you can run them locally. You can install Python and test them. Or, as we say here, you know, they can be managed within Movicon itself. So this opens up a very good way of having an additional programming language that gives you maybe a few more capabilities, but is also a more modern language for the younger programmers. Now we're going to take a look at database logging. Now, database logging is very important to store historical data, and that historical data can be used for a variety of purposes. So historical trends, reports, but also for analytics that require the use of historical data to be able to make calculations and then perform operations based on both that historical data as well as current operating positions. So we have two effective ways of storing data in Movicon. We have historians and we have data loggers, and all of those operate on IO tags. You've also got the option as well of using a VB script or a Python script to do your own database logging, but those are more for special applications. It's much easier to use a historian or data logger for storing data. So what the historian manager does is it manages the recording of tags from the IO data server, and then you've got either the option of using a historian type table or a data log table. They both have the same function, which is to store IO data, but the way they work is that generally the table formats are very different. So if you're using a historian, it stores one IO tag value per record. And the reason for doing this is it can potentially give you more columns with more information, but what it does mean is that maybe the performance is reduced because each record is calculated as an individual transaction. So it's one IO tag per transaction or per record. So recommended for IO tags that do not change frequently, but it also gives you additional capabilities like storing previous values. So for 21 CFR 11 validation, you can do things like make sure that the new value and the old value are correlated and you haven't missed any values. Now what the data logger does is this stores multiple IO tags per record. So recommended for trends, it gives you better performance for trends, and also for time series type data and IO tags that change frequently, a data logger potentially gives you better performance. Inside Movicon, data loggers also give you better performance because of the way they work. So data loggers use a .NET framework provider, whereas a historian uses ADO.NET XPO providers. So the .NET framework provider potentially has higher performance, but we are depending on the .NET performance for this here. Now, the big benefit of data loggers is really that because you're storing multiple values in a single record, if you have a trend that's displaying those values, then the read performance to read that data back is much faster, because instead of having to read multiple records for all of the variables, you can read a single record that gives you all those values against a single timestamp. So it is potentially a lot more efficient for retrieval of data, but it can also be more efficient for writing of data. But again, it depends on what your use case is. You might use a combination of those, or you might use both. And it might be that depending how your application works, one might be more efficient than the other. And you might not know until you get out into the real world as to which one is best. But both of them store data, and both of them we support for standard databases. So it's SQL Server, which is Microsoft SQL Server. For the ADO.NET XPO providers, we also have interfaces to SQL Azure. We also then support MySQL or MariaDB, SQLite, which is a nice low proprietary database that just gives you very high performance. It's just file based. We support Postgres and Timescale DB. And with the XPO providers, we can support any XPO provider connection string. With the data loggers, it's anything for which there's a .NET framework provider. So that includes databases like Oracle. So that's another issue why you might use one over the other. You'd need to check what your database supports in terms of these different mechanisms. Now, generally in terms of performance, database performance varies, but if you're using SQL Server, that's benchmarked to up to 2,000 transactions or 2,000 records per second. But if you're using something like Timescale DB, then potentially you can have up to 150,000 records per second. So there's a lot of difference in performance there between the different databases. So that's another aspect. You would choose your database based on its performance. But also what we find is a lot of end users have their own preference. So they might already have spent a lot of money on Microsoft and they might have an SQL Server instance that they want you to use. Maybe they're open to open source databases, in which case they may have a preference there. And for small applications, you might use SQLite, which is that very low cost database, which is file based. It doesn't even have a database server. The way that works is the application itself supports the SQLite data writing and data reading. And with Movicon, we've got that SQLite interface built in. Now, if you've got a remote database, we do support store and forward. So if you're communicating with a remote database and the database network connectivity is down, or maybe the database is offline for maintenance, then what Movicon does is when it detects a database failure, it starts logging the data into a local XML file. It then continues to monitor the database connection, and when the database recovers, we then forward the data in those XML files to the database to make sure that there's no data loss. External databases can also use OPCUA or MQTT, so you could also use a driver to interface with the databases, so you don't have to use the built-in applications, but certainly those built-in historians and data loggers, yeah, they make the most sense in terms of having a simple interface. From a visualization point of view, yeah, we've got a data grid. Yeah, we've also got the possibility of using a trending, of course, and reports. Yeah, all of those, they use a SQL connection to the database in order to be able to display the data. Now, some databases don't have a direct SQL link, but there are some databases, particularly historians, where what you do is you create a SQL link table, typically using SQL Server, and then that gives you the link to your actual database. So you're not reading the external historian directly, you're actually reading a linked table. So for example, we used to have a historian when we were part of GE, and that GE digital historian, that uses a SQL link table in order to be able to read data. And as I understand, other databases like Emerson's IP21 and so on, they can also use that SQL link table. So it might be a historian that doesn't have native access from Emerson's Movicon, but what you could do is you could use that SQL link table for Movicon access. Now, a traditional problem with using an SQL database is database management. So the great thing about Movicon is the historian manager can automatically delete records which are older than a defined age. So what there is inside the historian and the data logger settings is there is a maximum age setting, and that determines the date at which older records are deleted. So you can set that from anywhere from, say, 30 days to delete anything that's older than 1 month, and you can set that all the way up to 9,999 days. And by doing that, it deletes any records which are older than that number of days. The benefit of doing that is it means you don't have to spend that much time on database management. You would need to do some management around how big is your database going to get, because you wouldn't want to exceed your available hard disk size, or in the case of some databases, you might exceed the file size or the database size available. But by doing those calculations, you could then determine maybe you want to keep 3 years worth of data. So you could keep, what's that, about 900 days worth. You could set your maximum age at about 900 and whatever it is. And then anything older than that 900 days would be deleted, but that would allow you to keep your 3 years worth of data. And the benefit of doing that is then you don't need to do additional data management. Management will be automatically performed by Movicon as it writes data to the database. Now, another option you've got for data logging is aggregated tables. One of the issues of having data is that if you're storing a lot of data, there can be huge amounts of data to manage, and it can be very difficult to do simple calculations. So with aggregated tables, what we can do is we support automatic creation of summary tables and data that can be aggregated every minute, every hour, and every day. And what happens there is inside the database, we do some stored procedures and we create additional tables, and within those additional tables, for each data item, we have minimum, maximum, and average values for the defined period. So the benefit of doing that is it means that rather than keep all of the raw data, you can delete the raw data that you no longer need, and instead you can use that aggregated data. Because it might be important at a short term that you know what the actual raw data is, but after a few hours or certainly after a few days, you probably don't care what the individual temperature was last week on Tuesday at 3 o'clock in the morning, for example, unless there was some sort of event associated with it, in which case you might also have an alarm record. But what you might be concerned with, what was the minimum and maximum value on Tuesday, and what was the average value? Yeah, that might be more useful than determining those individual values. So this is a way of reducing the amount of data you store and also being able to get quicker access to these aggregated values. Now there's another way of reducing database storage and network bandwidth. First of all, we've got something we call dead banding, and you do this by setting a deviation value. So if you've got a value that's maybe an integer value, you might store on change, but what you might say then is, in order to avoid sending every single value change, maybe you're recording a level, and the level might be 50% with a value of 50, but some level meters, that would oscillate between 49 and 51%. So rather than say store all of those data changes where you're just measuring the ripple on top of the surface inside your vessel or tank, maybe what you do is you'd set a dead band of 2 or even 5, and then you would only record changes when they exceed that deviation value. So that way you're not recording those small ripples, you're only recording the actual bigger changes, and that can significantly reduce the amount of database storage you need. And of course, if you're sending data over a network, it reduces the amount of network bandwidth as well. Another option you've got there is minimum interval and maximum interval settings. So you can control recording on change or on time or mixed. So you can record on change, you can use a dead band, but what you could also set is, you might say, well, I'm worried that if the value stays at around 50%, I might not see a change for some time. So you could set a minimum interval and you could record every 5 seconds, regardless of whether it's changed or not. So that's in addition to on change, or maybe instead of, maybe you only want to record every 5 seconds. So you wouldn't use an interval, you just use that minimum interval rather than on change, and then you could say record every 5 seconds. Another option is to set the maximum interval setting. Again, this allows you, if there's no changes over a particular time, you can set the maximum interval, and this can only record at that maximum time. So again, if there's not much changes happening, then you can actually make sure that you do at least log some values at some time. This can be useful for 21 CFR 11 applications, where you might want to record at some times regardless, just to make sure that you are recording all the parameters. But again, it's a great way of removing or reducing the amount of network bandwidth and the amount of data storage you need to do. You also got an enable tag, so it's also possible to disable logging when an IO tag is not in use. So that's another way of reducing network bandwidth and reducing database storage. If the tag's not in use, maybe because you've got a process where that part of the machine or that part of the process isn't being used, you could disable logging for that IO tag. Now, depending on your database, Timescale DB is good for this. Some databases also support compression to reduce disk space, and they use a combination of these techniques above in order to only use a certain amount of disk space. So you've got an option there. You can do all of your calculations and optimization inside Movicon, but it might be easier to use Timescale DB, and then Timescale DB does its own compression to reduce disk space. So that can be easier if you want to manage a large amount of data rather than trying to think about doing it for every single tag inside Movicon. Or you could do both, and both techniques, both mechanisms can be very effective in reducing database storage and network bandwidth. So we've talked about the historians and data loggers for storing data. We do have additional databases in Movicon as well. And these are generally SQL databases via ADO.NET XPO providers, and these are configured at the project level. So first of all, we have an alarm log, and this stores alarm and events. So the idea there is whenever an alarm occurs, or you can configure an event which is the same as an alarm, but it doesn't appear in the alarm list. So the idea there is that whenever there is some sort of thing you want to log, then that can be stored into the event log. So this has a defined format and a maximum age of 999 days, but it allows you to store and then display all of your alarms. So we do have a default historical alarm log, and you can also display alarms using the reporting function, or you could export those alarms from the database and you could use them in an external application. There's an audit log. The audit log stores things like user login and user logout, and it also records user and user group creation and modification. So that's very good for auditing who does what inside the application. And then the other database we have here is a recipe database, and this stores recipes and related data. So it reports when a data was created, when a recipe was created, when it was activated, when it was uploaded and downloaded and so on. So that's the recipe database, which is used if you enable and use the recipes option. And then finally, there's a system log. By default, that's an XML based file storage which stores system events. So when Movicon starts, when it stops and so on. But that system log can also be an SQL database as well. But the idea of that is, that records system level events, and that can be used for diagnosis in case of failures, and also to work out what your application is doing if you have any issues with Movicon. We're now going to talk about Movicon redundancy. For high availability operations, Movicon Next does support server level redundancy. This is ideal for applications where server downtime is not allowed in the event of a failure, but failure of computers isn't the only issue. Maybe you also need to think about maintenance of a server. So these days with cybersecurity, you regularly need to apply patches to the operating system, and maybe you even need to update the application itself or other related applications. So for example, maybe you're updating databases, maybe you're updating other system components. So it's quite common to need some sort of computer reboot, and in order to avoid downtime during that computer reboot, this is where Movicon Next server redundancy can come in. So what we support is N+1 redundancy with a master server and up to 3 backup servers. So if the master server is running, then it performs the majority of your data collection and all of your applications. But the actual client loading, is spread across all of the servers. So the benefit there is that if you've got a master server with 1 or more backup servers, if the master server is down for whatever reason, then you've got those backup servers that take over both all of the master functions, but it also allows you to load your different client sharing across that available pool of servers. So if you've got a lot of clients, that can avoid a big sudden jump in the load on the backup server compared to having it spread across the 2 servers under normal situations. So for example, imagine you've got 100 users, 50 would be on the master server, 50 would be on the backup server. If the master server is taken down, the system has to handle that sudden flood of 50 users onto the backup server. So to reduce that load, you could improve the server resources, but another option would be to add another backup server, and then you'd have 33 users across each server. And then if that master server was offline, then you'd only be distributing about 18 users between each particular server rather than that 50 as before. So it's a way of pooling and load sharing of clients, which is why you might want more than one redundant backup server. Now, client redundancy, that can be implemented using multiple clients. So there's no real redundant client as such. What you would have is 2 clients, and if one failed, the user would switch from using that client they're normally using, and they would have a separate computer, and then they would log on using that separate computer. So that's the way that client redundancy would work. And we also have redundancy support for various device drivers. So some of the device drivers have 2 IP addresses for a master and a backup PLC. We also support redundant networking. We support redundant historians and data loggers, and we can also support redundancy for the event logs, alarms and recipes and so on. So lots of redundancy available there, and redundancy, it's all about having 2 or more servers, 1 or more backups, and the whole idea is if the master computer is offline, then the backups take over. So here's what a redundant server architecture might look like, and this gives us fault tolerance for any single point failure. Now, it's hard to draw these redundant applications because they tend to get very complicated in larger systems because of all the Ethernet LAN connections. And this is where you have to think about all the network switches that will be involved, and you need to configure appropriate network design. But effectively what you have here is you have your primary server with a backup server. So they're your Movicon servers. You then have a client with a backup client, and then you'd have your primary PLC with its backup PLC. And all of the devices are internetworked in such a way that for every device there is a backup network path as well as the backup device itself. So there's quite a lot of complicated configuration required here around IP addressing, and you may need to use appropriate network redundancy as well. So yeah, your network might be simplified by using STP, scanning tree protocol, or rapid scanning tree protocol. Yeah, that can simplify your network configuration rather than rely on all the networking at the Movicon level. So in a server redundancy application, the way the system works is that the active server collects data from the devices and it executes the events and logs all of the data. The active server also synchronizes data, alarm states and recipes to the backup servers. In order to do that, we do use a dedicated synchronization network, and this uses UDP over whatever the local network that's configured. Because it's using UDP, this can't be routed, so that means it must be on the same network, the same subnet. Backup servers do not collect data from devices or execute events or log data. Now, if the active server fails or is shut down, we have this N+1 redundancy, and the next backup server in line takes over as the active server. So as soon as it's the active server, it's performing the active server functions, which is collecting data and synchronizing data. If the primary server returns to operation, then it would automatically restore its state from the currently active server, and as soon as synchronization is complete, that restored primary server then resumes as the active server, and whatever was the previously active server, that returns to its backup server status. Now, if you've got systems with two servers, you can configure the backup to retain control, but in most applications what you've got there is like a preferred master status, which makes it easier to manage the system. But you can have like a configured system where you keep control if you want to. Now with the clients are automatically connected to any one of the running servers using a load balancing principle. So if a client is connected to a server that fails or shut down, then it automatically searches for another service to provide continuous operation. So the clients, they connect to any of the operating servers, not to any particular one, and that's transparent to the user. So server redundancy operation is quite straightforward. It is configured inside the Movicon developer, and what you do is you define the master server and the backup servers, and you need the appropriate networking as well to make sure that you've got that synchronization capability. But it's relatively straightforward to implement. You do need the redundancy option, but otherwise there's minimal configuration involved in the actual server redundancy operation itself. Now with the current version of Movicon, redundancy support includes device drivers, historians, data loggers, event logs, alarms and recipes. But some aspects, although they can be used in a redundant system, they aren't managed redundantly. So for example, event objects, alarm dispatcher and schedulers, some of those you might find that you get both servers in a hot standby system are performing that. So that might cause issues. This is something we're investigating and continuing to prove. So each successive version of Movicon does have better redundancy support. Now for database redundancy, this can be implemented at the database server level. So if you've got Microsoft SQL Server, then you can use a combination of the Windows Server failover clustering, also known as WSFC, and you can use SQL Server redundancy or some similar approach. Now Microsoft don't recommend this, but it is possible to combine servers as well. So instead of having huge amounts of computers, then you can combine servers, and that allows you to have a combined domain controller and a cluster and a database in the application, because otherwise the risk is that you end up with lots of computers. And of course the computer hardware providers, they like this. Microsoft like it because you have to buy lots of server licenses, but it can get very difficult to manage, particularly at an OT level. So if you're an IT person, maybe that server failover cluster is already there, and maybe you've already got SQL Server redundancy, But if you're an OT person implementing a smaller application, that's probably a lot of extra overhead. So you can get around that, but it does require some careful consideration. Now, network redundancy, that can be implemented, and usually that's done at the network level. So you can use teaming of network adapters with a single IP address, or you could use switches with multiple protocols such as STP and RSTP. There's also MSTP as well. So yeah, redundancy at the network level, that's now often implemented by the network itself rather than by having multiple network adapters and application management control. And again, if you need multiple interfaces in the same computer, that's where teaming of network adapters can be supported. For redundancy configuration, the process to use is here. So first of all, you need to design your architecture. So you need to consider how many servers and clients are there. You need to do your IP address mapping. And once you've done all of that, you can then start to create your project. So there is a redundant project wizard, but it's also possible to add redundancy to an existing application by configuring server redundancy settings. So first thing you do is you configure your network transport. Today that's easy because we only support net.tcp. In older versions of Movicon prior to 4.4 there were other options, but today it would be net.tcp. You then configure your synchronization parameters, which is things like keep alives and so on, for how long that a server will run for before it fails over. You then configure your redundancy server list. You then configure I/O drivers for redundancy if required. You configure the backup server connection parameters for the clients, and then you would deploy or copy your project to all of the computers, and then you'd also configure your I/O data servers, etc., to start automatically. That last one is optional, but it's a good idea to have it started automatically. Otherwise, you would need someone present to actually start Movicon. So there's no special configuration or programming techniques required, but there is a bit of extra planning in order to determine what the computer names are and to actually do the configuration itself. And then there would also be that separate copying stage along as with configuring services to start automatically. So slightly more work, but not really much more work than you have with a standard application. The OPC-UA I/O driver is a special case. Movicon does support OPC-UA client driver redundancy, and the way this works is we're using a special aspect of driver redundancy, which is around transparency of redundancy. So what happens is when the OPC-UA server supports redundancy, it exposes a list of redundant servers for the driver to read. And then what happens is the driver automatically looks at communication with the primary server. If that fails, then the driver will try to communicate with the next one on the list. So with PAC Systems PLCs, this is implemented using OPC-UA non-transparent redundancy. So the way that works is the client is responsible for connecting to the two CPUs and swapping in the event of a failure. The opposite is transparent redundancy, where the servers, the PLCs, are responsible for performing the swapping and so on. So in the case of PAC Systems PLCs, we do support OPC-UA non-transparent redundancy, both in Movicon and in the PAC Systems range. And then that automatically works. It's just a matter of configuring that in order to work, and then having the appropriate networking architecture, and then it will automatically swap over. Note that non-transparent redundancy is only supported by redundant PLCs. It's not supported by standard PLCs. So you have to use a CPE 330 or an edge controller configured for redundancy. Now, PAC Systems does have a redundant IP address, but the redundant IP address doesn't support OPC-UA. So what you would need to do there is, if you wanted to use the redundant IP address, you could use the older Emerson Ethernet protocol, or you could use Modbus TCP. They do support the redundant IP address. But for OPC-UA, you don't use that, you use that non-transparent redundancy. Now, ideally, you want to use the latest version of the PAC Systems firmware, PAC firmware version 11. That's the one that now publishes the primary and secondary endpoints, even if they're not accessible on the primary LAN. So that one gives you the capable of both hot standby PLCs and a master and backup network. So make sure you're using the latest firmware, and you'd also need to look at using the latest version of Movicon, because we have enhanced the OPCUA capability with successive versions. So 4.4 does update OPCUA stack. And also the latest PAC Systems firmware, that gives you better OPCUA performance, as well as properly publishing all of the endpoints. Now in the OPCUA client driver inside Movicon, you can enter a backup host list there, so you don't have to rely on the PAC Systems PLC publishing all the endpoints. The way you can enter multiple addresses is separating them with the pipe symbol, which on my keyboard is the key immediately to the right of the left shift key, and that gives you that pipe symbol. So for example, you can enter in your IP addresses here for the master and backup devices. So here I've got 2 LANs and 2 devices. Each device is on 2 LANs, and I've got 2 networks there. So I've got 192.168.0 for my primary LAN, 192.168.1 for my secondary LAN, and then my device addresses are 101 for the primary PLC and 102 for the backup PLC. So that's 4 IP addresses, and the way I enter them is as I've entered them here. Okay, now your mileage may vary. Not every PLC supports this non-transparent redundancy, so that's where maybe another protocol option might come in. And with OPCUA, this is the way it works, but with the other drivers, they have alternative mechanisms of doing redundancy. So for example, with some of our other protocols, what you get there is a more simple way of doing the master and backup. So you have the master or host IP address, and then you have a redundancy or backup IP address, and they are 2 separate options within separate areas in the driver configuration. But the challenge with those is, they often give you a master and a backup PLC, but they might not handle the network redundancy. So again, that's when you're into RSTP or something, but RSTP might not be fast enough on the control network. So at least with PAC Systems and using OPCUA, we've now got full support for this redundancy operation. So here's how you can use the Emerson SRTP protocol, which is what PAC Systems PLC supports. We've also got Modbus TCP IO driver, and these work with redundancy with this host name and a backup host name, as I mentioned. So for redundant networks, you could use the redundant IP on the first port of a PAC Systems PLC, and then redundant IP on the second port of a secondary network. So that's more PLC configuration. But the challenge there is that not every PLC supports redundant IP on the second network if it's also being used for Profinet. So it's a bit harder to do this. So I recommend, where possible, use OPCUA, but we do have support for redundancy on these legacy networks. And this is also supported in a similar way on other vendors' PLCs, but the other PLCs may not support that redundant IP, so then you just have a single IP address with a backup IP address. So you might need to do a bit of investigation with what your PLC supports if it's not an Emerson PLC. So these are example fault-tolerant redundancy architectures with sample IP addresses. So the one on the left is using a PAC Systems RX3i rack-based controller. So this would be a CPE330 CPU using the RMX synchronization. And the benefit of doing this is that you can have 2 IP addresses in the controller using either the individual controller network ports, because the CPE330 has 2 ports, or you could use a separate IC695 ETM001 module. So this would give you the benefit of separate Ethernet ports and being able to communicate directly using these multiple IP addresses. So you can see here that because we've got all these different IP addresses, the networking configuration can get quite complex, but effectively at the higher level, you've really got 2 networks. So you've got your master network on 192.168.0, you've got your backup network on 192.168.1, and then you assign your IP addresses accordingly. Now on the IO side, the IO network would be a separate network, because with the CPE330, you've got the option of using either the separate Ethernet module in ETM001 or a separate Profinet controller, and the benefit of that means you can segregate all of your networks. And one of the reasons that's important is, certainly when you want to go to fault tolerance on the Profinet network, you can do that with an MRP ring. But as soon as you've got a ring, then that means that normal network operation is very complicated. So it would be very difficult to mix this architecture on the left with a Profinet MRP ring. So if you were using a CP400 or CPL410 edge controller, then it could look something like this. So you'd have the same configuration at the top as before, but now you've got the issue of how do you connect to the actual PLCs. So the primary network is straightforward, 192.168.0, you've got the same connection as before. But on the secondary network, what you could do there is you could use a GLM switch, and the GLM switch allows you to connect a non-Profinet device to the Profinet ring network. So the Profinet MRP network is in green. And again, this is on a separate subnet, but now what you've got to do is you've got to use that GLM switch in order to connect your backup network to LAN 2 port on the CPE400 or CPL410. Now, you could have two network connections, but there's no point, and also that would potentially create a ring. So what I'm doing here is just a single connection from my secondary Ethernet switch to the GLM switch, and that gives me my backup connection. So yeah, it's a very different architecture, but it gives us the same effective support. But now we do need that additional GLM switch. But certainly if you've got edge controllers and you want to do redundant communications with redundant LANs, it is possible. I would argue though, why do you need a redundant LAN if you've already got redundant PLCs? Yeah, if you're looking at surviving any single point of failure, your first failure, if it's on the first LAN, provided you don't have a single point of failure with your network switch, then it would be feasible to say, well, I will just have one connection, and then if that connection fails, my secondary PLC will take over. But yeah, you could argue then that there is a single point of failure there, which is the switch itself. So unless you've got some sort of redundant switch arrangement, that secondary LAN arrangement, that does give you that additional level of fault tolerance. So as I say, a bit more complicated to set up with Profinet, because Profinet rings don't necessarily work well with redundant networks. But by doing it in this way, with this architecture on the right, this does allow you to have full fault tolerance for any single point of failure. Let's move on to cybersecurity. For cybersecurity, Movicon Next is certified as compliant with IEC 62443-3-3, and we have Lloyd's Register Quality Assurance for compliance with that level of the particular standard. Also, Emerson itself, Emerson is also certified to IEC 62443 with our secure development process. So we are compliant with IEC 62443 at multiple levels. So the purpose of this compliance, it gives us enhanced security. So this compliance makes sure that the SCADA system is designed with high security control levels. One of the ways we do this is with user management. We cover risk management. So we're mitigating standard SCADA risks. We're looking at the regulatory compliance, which is what we have from the Lloyd's Register. Data protection. By using OPCUA with certificates, data is secure while transmitted, and also we can use the various different database aspects and computer operating system aspects to actually secure the data while it's being stored. System integrity is good, and we can make the SCADA systems more resilient to cyber attacks. One way of doing that is, first of all, with all of these extra protocol elements, but also potentially by using a hot standby system. And then that leads to operational continuity, which gives us critical industrial and infrastructure application support with this continuity using redundancy type support. It also ties into user management, and we have user management and group management. But one of the key aspects is that Movicon Next is only a small part of the solution. You also need to consider the operating system. So you'd need to make sure your operating system is hardened, and you need to keep things up to date. So although Movicon Next has this IEC 62443 certification, and so does Emerson, it's only a small part of the system. You've also got to consider your PLCs, you've got to consider your client network, you've got to consider your database, You've got to consider your computers and your operating systems. So it's all very well having Movicon Next certified, but that's only a part of the application and it's not all of it. So I mentioned some of these aspects, but these are the key ways of making sure that your data is protected. So we do support project protection, and what you can do there is you can encrypt and protect the Movicon Next project using passwords. So the idea there is unauthorized users cannot access or modify the project. So you've got the protection of the project itself. I mentioned user management, so there is full user authentication and runtime access control, and you can manage who can access what data within the application during runtime by using user and password management, and that also extends to multi-factor authentication if required. Now, a lot of that is controlled by the operating system itself, and that's where we get that integration with Microsoft Domain and Active Directory, so that might also be part of your security mechanism. But it does allow you to tailor access and protect controls and functions, and you can select the appropriate authentication for different functions. And then, as I mentioned, underneath you've got OPCUA. The Movicon communication layer is based on OPCUA. So we've got a multi-layered architecture between server elements and also between servers and clients, and also between computers and PLCs, and also in theory between the databases as well, but that's maybe outside of OPCUA. But this multi-layered architecture, by using certificates, we have very comprehensive security across those different components. And the way that works is using public key infrastructure with certificates based on OpenSSL, and that's what controls that connectivity. So there is an additional layer of management there. You do have to think about copying the certificates around the system to make sure that clients can access servers. But the benefit of using certificates, it means first of all the data is signed, so you know that the person it's coming from or the computer it's coming from is correct. But also the data could be encrypted so that no one can read that data. So encrypted data means that you're now prevented from man-in-the-middle attacks. No one can now change that data without you knowing about it, and no one can steal your secrets. Another benefit of certificates is if, say, you had a user that was using the system and they left the organization, or maybe you've got a computer which you've decommissioned, what you can do there is you can revoke that certificate. So an application that's no longer in use can be revoked, so then it will no longer have access to the system. So that gives us lots of benefits in terms of safeguarding your know-how, customizing access, and achieving compliance. So for my last slide, I'm going to talk about Movicon releases and where we are up to right now at the time of presenting this slide deck. So Movicon 4, which was introduced in 2020, was a completely redesigned platform based on the latest .NET and OPCUA technologies, and this was also the first release of Movicon available under Emerson. We then moved to roughly about an annual cycle of improving and increasing new releases. So in 2021 we had Movicon 4.1. In 2023 we added Movicon 4.2 with some new drivers. In Movicon 4.3 we added some redundancy enhancements for recipes. In Movicon 4.4 in this year we added some more new drivers including DMP3, we added the Python capability, and we added timescale DB support. So there's a very long list of overall improvements. It's not limited just to these things, but each year we're updating the underlying technology that helps us improve performance and increase cyber security. Of course, we continue to fix bugs. We are supporting newer operating systems, and there are multiple ongoing enhancements with each release. So Movicon continues to improve and be enhanced, and this will continue forward into the future.